Okay, so we're going to draw a cooling curve. It's there on the screen. Draw a cooling curve for a substance beginning at 160 degrees Celsius and ending at 75 degrees Celsius, negative 75. The heat of fusion is 45 kilojoules per mole. The heat of vaporization is 102 kilojoules per mole. The melting point is negative 25.0 degrees Celsius, and the boiling point is 70 degrees Celsius. I know that's wordy, and there's a lot going on, but all we have to do is just get that information. The rules we're going to follow is what you see on the screen. We want to determine from the question the beginning temperature, the end temperature, the melting point, the boiling point, the delta H of fusion, the delta H of vaporization. And then the last bullet point is if they don't give you a beginning temperature and or end temperature, then you pick based on that following information. In this case, this problem, we don't need to worry about that just yet. So we're just going to move ahead with the problem. Okay, your paper's set up. Unit 4 heating and cooling curves. And here's the 6 items I have to look for. Okay, I'm just going to read the problem. And as I read it, I'm going to fill it in. Okay, that's all I'm going to do right now. It says, draw a cooling curve for a substance beginning at 160 degrees Celsius. So that's my beginning temperature. 160 degrees Celsius. Okay, and then it reads, and ending at negative 75 degrees Celsius. So negative 75 degrees Celsius. The heat of fusion is 45 kilojoules per mole. 45 kilojoules per mole. And the heat of vaporization is 102 kilojoules per mole. So again, I'm just reading and writing down the information I need from the problem. There's nothing to figure out. It's all clearly labeled. Okay? The problem continues. The melting point is negative 25.0 degrees Celsius. And the boiling point is 70.0 degrees Celsius. Actually, just 70 is what it's written on the problem. So just like that. That's my beginning information. Okay? And again, here's the rules that we're going to follow. So we're going to determine from the question all those items which we just did. Okay, we just did that. So now what we got to do is actually, what do we do with that information? So if you can see on the screen, okay, this is a cooling curve, which is right there. And it says plot the points, plot the following 4 points from left to right by decreasing temperatures. So I need to look at the 4 temperatures, okay? And I have to plot them from left to right by decreasing temperatures, and it's a cooling curve. Okay, so I look at these 4 temperatures, and I figure out what's the highest temperature. There's the highest temperature, so I'm going to label that number 1. The next highest is number 2. The next highest temperature is number 3. And the next highest is number 4. There is my 4 temperatures from highest to lowest. Okay? Here's some side notes. The beginning and end temperature are going to give you the y-axis and y-axis range. Okay? So this gives y-axis range. Okay? So these temperatures kind of make you figure out what the y-axis has to start with and end with so you can fit everything, all the data in there. Okay? And then these are the plateaus in the drawing. The areas where it's flatlined. Okay? So what I need you to know about the plateaus, so I'm going to write plateaus. It's a funny word. And we're going to say make larger value wider. Okay, so out of 45 and 102, 102 is the bigger number, so when I draw it, it should be wider left to right. Okay, it's just one of those little things that you need to do. Now it's just time to draw. So if I look here, and this is all freehand, okay, so here's my drawing. All right, I'm going to push it. Actually, I'm going to just go like right around. Here's fine. Again, this is freehand. I'll zoom out a little so you can see it. Okay, just like that. Okay, and now let's look at the directions. What do we need to do with that information? Plot the following 4 points from left to right by decreasing temperature. Okay, so that's what I'm going to do first. Okay, and I'm also going to set up my y-axis range. Okay, it says that 160 is the highest temperature, so I'm going to put that right there. And the lowest temperature I'm going to achieve in this problem is negative 75, so I put that right around there. Remember, I'm just eyeballing it. And then if that's 75 and that's 160, that means 0 is somewhere right around there. Okay, now I plot these from left to right, from highest to lowest. Okay, and that's why I order them. So number 1 is 160. So I'm going to put that like right around there. Okay, so notice that 160. And then it says I go to the next one and just plot it over to the right a little. The next temperature highest is 70 degrees. 70 degrees, probably somewhere around there. Again, these are just eyeball values. Okay, and I just move it over a little bit, and I put it right there. Okay, the next highest temperature is negative 25. Negative 25 somewhere down here. And again, I scoot it over more. I just keep going to the right some more, right around there. Okay, they're not going to be perfect. And then my last value is negative 75. I already have that, and that's going to be somewhere just like so. So there's my 4 value points plotted. I know it kind of looks like a straight diagonal line, but that's just the way it came out because we're just eyeballing everything. But notice the directions, okay? Now it says connect the dots from 1 to 2. So I connect the dot from 1 to 2, like so. Okay, there I just connected the dots. Okay, the next thing says I plateau from 2 and I diagonal to 3. So what does that look like? Plateau means straight across. I plateau across, just like so, and then I diagonal to the next one, like that. Okay, look at the rules. Then it says I plateau again from the dot I just made, and I diagonal to 4. So I go back here. So I plateau again, and then I diagonal to the last dot. All your cooling curves are going to have this shape. Diagonal, plateau, diagonal, plateau, diagonal. And notice as time goes by, the temperature decreases. A heating curve is going to do the same in the opposite direction. Look at the screen. I go diagonal up, plateau, diagonal up, plateau, and diagonal up. So it's a stair step the other way. Okay, but this is a cooling curve. Okay, so now I've plotted my points. I've drawn my line. So what do I do next? I go back to the set of notes. And then it says plateau from 2 to 3 and plateau from 3 to 4. We did that. And the plateau with greater delta H is wider. Okay. The vaporization plateau is wider because it has a bigger number. And the vaporization one, even though you're not familiar with it just yet, is going to be this plateau. The vaporization one is always the one that's warmer. But notice it is a little bit wider than this one. Okay, this is one of those things that we try to do. It's always not going to work out perfectly. Okay, but that's how it does work. All right, back to our notes. So what are we going to do in the end here? Now I just got to label it. Okay, that's it. I just got to label it. So I need a y-axis label and units. Okay, so I'm going to put this like this, and I'm going to put temperature. And if you fail to put any of these, it does cost you points. Temperature in degrees Celsius. It also says to put an x-axis label. X-axis is just time. Okay, there's no seconds or minutes because we don't mention any of that. So that's the labels, and they're nice and neat. Okay, so I have y-axis title units. X-axis just needs the title. I need 3 phases labeled. Okay. You guys should kind of understand that as things warm up, they vaporize. They become gaseous. Okay, the diagonals, therefore, the diagonal that's the most warmest, the hottest diagonal is this one. It's got the hottest temperature. That's the area where this molecule or this substance is a gas. The next diagonal, as it cools down, it becomes a liquid. Okay, and the last diagonal is solid. Okay, so those are the 3 phases: solid, liquid, gas, and it's always in that order. The solid always goes on the lowest diagonal, the liquid is always in the middle, and the gas is always on the highest diagonal. Whether it's a cooling curve like this one or a heating curve, that's irrelevant. Okay, what's next? 4 labeled arrows. And again, we haven't done this, so you're not too sure. but here's what you're going to find out. You have to put arrows here that describe the transition from one phase to the next. If I go from gas to liquid like that, okay, that's going to be called condensation. If I go this way, like that, that's called evaporation. Okay? On this side, from liquid to solid, I think you guys know that when we take a liquid and we make it solid, that's called freezing. And then when we do the opposite, it's called melting. Okay, so there's my 4 labeled arrows. And again, you get to use a note, so you just have to follow. Okay, but that is when you go, a gas goes to liquid, it's condensation. And from liquid to solid is freezing. If I go the opposite way, from a solid, I melt it into a liquid and I evaporate it into a gas. That's how we read that. Okay, as far as what else do we need to do? Both delta H values for plateaus. Okay. Once you write the arrows, just remember that when you see that word vapor, that kind of signifies to you that's the plateau for delta H of vaporization. Delta H vaporization, and in this case it was 102 kilojoules per mole. And then I labeled this one over here. That's my other plateau. That's the delta H of fusion. Fusion is always connects solid to liquid, so that's why it's always lowest on this diagram. Okay, if that kind of makes sense. 45 kilojoules per mole. And I think we're done. Okay, if you guys take a look at this, you can see that I have all the data there. I have the labels that the notes have asked me for. Everything's done. In general, a cooling curve is always going to look like that. Okay, even if the values are different, I'll show you another one right now so you can see that they're going to have that general same look. Okay, and it looks like this. This is a different problem. It's not the same problem, but you can see the general look is the same. Okay, all right, so that's how you do a cooling curve. Hopefully that helps you guys out.